Hello, I'm Reece, and I'm here today to talk about Local-Interchain, our testnet platform that we've built out to help developers build out their applications easier, as well as help protocols test in complex scenarios. So what's the problem? The interchain environments currently are too difficult to set up and interact with. We have a lot of bash scripting. This is a pain to deal with. It's so cumbersome. There is too much hassle in trying to figure out how to get these chains to connect together. And as coming into the ecosystem, you don't even know what you need to touch. It's very scary. If you want to test multiple binaries of a chain where you want to run Osmosis 24 and 25 on the same network, you're dealing with 4 different kinds of ports. You need to modify the config files, and you always mess up that, and you need to restart. It is a pain. The configuration of this with Genesises and having to modify that and set up relayers and all of these other things, they're just a nightmare for end-to-end testing. Skip's going to notice this, as they talked about earlier, like it's hard to set up these environments. We need to set these up. How do we do that in an easy way that we can easily configure that to others as well? So we want to be able to use any chain in Cosmos. Any programming language should be able to be run against this. So if you're familiar with Python, great. If you're familiar with Rust, great. We don't want to force that upon you. We want you to use anything that you feel comfortable with using. We need to support every operating system, especially Windows. Most people in here are using Linux and Mac OS, but we need to support the Windows developers as well. This is an important area of the market that's not been captured yet, especially within testing frameworks in Cosmos. We need to be able to override any setting. So if I have a chain and I want to change something, I should be able to do that. By default, we should give default Genesis values. It's important to do that. And then we need to give the option of configuring nothing or configuring absolutely everything, because we want users to feel comfortable with it and then become more power users as they grow. So Local-Interchain is this tool, and we're helping to remove the pain from the interchain. So day one, already today, we support every single Cosmos chain. As long as it is a Docker image, you're able to use it. We also support Ethereum, so you're able to launch a Ethereum node locally with your other networks as well. And we have Polkadot and Penumbra support. However, they're not hooked up yet, but all of the code is there and the base infrastructure is set up. If you're interested in this, happy to set this up. Come talk to me after. We support Windows, Linux, and Mac on both ARM and x80 and 64-bit. So we support every operating system. That's very important to us. And then the biggest thing here is we support every programming language as well. So no matter where you come from as a background, you're able to write these tests for your organization. So right here, we've got a tiny Cosmos example that shows with some JSON of running 2 Osmosis nodes and connecting these via IBC. So we launched 2 chains. It's going to automatically connect these with the ICS-20 protocol. And you can use Hermes or Relayer just by running this simple command. You can use a local JSON instance here, and it'll pull it up. That's the name of the file over there. And then the other option is that you can actually upload this to a gist or run remote configurations. For power users, you can override everything that you want, including gas prices. You can change the coin types. You can override config files. You're able to modify the Genesis in place, the accounts that you want, as well as startup commands that you want. After your testnet has started, I want to run other commands. You can run those bash commands within this. We also have support for both JSON as well as YAML. So if you want comments, you can use YAML. We have support here for AVSs as well, where for Ethos, where we built out the Ethereum client on top of Local-Interchain, you launch it with this configuration. You're able to load in your test state of an AVS that is deployed there. It's automatically set up for you alongside your Cosmos networks. If you want a consumer chain, it's a single line. We automatically set up the relayer for you. We automatically set up all of the governance proposals. Everything is done, and all you had to do is just add that one line. That local Cosmos 1 is the chain ID of the consumer chain that you would have. So if you have multiple consumers, you just specify, I want to use that provider, and it'll automatically do it for you. If you're insane because you need to create a bunch of different IBC channels, then you're able to do that here and automatically connect those via the IBC paths in very complex configurations. Here we've got 26 Osmosis chains running, and a relayer is connecting all of these and multiple together, and it is a nightmare, but you're able to do that very easily. Maybe JSON is hard and you don't want to actually build that out. We have a JSON builder as well. So you're able to just specify and build on top of that with your specific values, and now you can easily build up more complex scenarios in a programmatic way. And in interaction, we need to support the current ways of doing things, such as using gRPC, RPC APIs. These are what most tools are familiar with, but we also want to bring in other applications on top of that if you want to use other programming languages. So we've got this API service. It's got just 3 endpoints and everything's handled through these. So the biggest one is info, just to see what all the data is. We automatically do the ports that are done there. So we automatically assign those ports. You can have those deterministic as well if you would like to override those in the config files. And then posting with chain interaction. So you're going to hit this endpoint and we can abstract away setups for you. This does everything through Docker. So it does not require any custom binaries for you. It's just all done through Docker. It's very good from a user experience perspective. We also handling uploading of contracts and abstracting that away. So if you upload a Cosmos contract, it'll automatically set that up, give you that code ID, and instantiate that for you if you would like it to, or you can just do it the normal manual way. We have a Rust client here, so this is running on top of Local-Interchain. So Local-Interchain is the base in Go, and then we have that middleware API, and then above that we have the where you're able to run through any request. So we're just doing simple HTTP request over into this middleware and running a native Rust implementation, but it's now going back down through the stack and handling everything for you. Other languages look the exact same. Here's a Python example. We use a contract, we instantiate that contract with our data, and it just works. And then if you wanted to do it in Bash, you can still do that, and here's some of the behind the scenes of how this looks with running a binary command. You specify the node index, what I want to run on that via the standard binary. And then with relayers, you're able to also do that via the relayer exec, and you can just run that for either Hermes or relayer. Another big thing is GitHub CI. You need to make sure that I can run that locally, but I also want to test complex environments ahead. So we do that through the GitHub CI, and all you do is download it, you run your testnet, and then you just run the standard test that you wrote in any language of your choice. With this, we're able to build up persistent testnets as well. So you've got all of the testing infrastructure, but I want to be able to also run these remotely or privately, depending on your use case and if your protocol is open source or not. And we have that support here. So through a GitHub action, you make a tag, and then it's going to automatically launch your testnet. In this case, we just launch it through Hetzner. So we spin up a new Hetzner instance, we set up all this bash, and it just does everything for you. From here, you can then synchronize external nodes. So you could actually bootstrap your network through Hetzner, and then from there begin to continue to build up through this. As I mentioned as well, private testnets. So if you want to have where no one else sees your code, you can do a self-hosted runner. It's all private, and it'll all work just the same. There is an authentication token you can also add. So if you don't want others to have admin access over, you can override that, or you can make that open so that way anyone that has access to that node is able to perform admin commands. I have a video here of contract-to-contract IBC with Python. So this is currently running 2 Juno nodes that are on version 17 with some accounts that are automatically set up for us and an IBC path between these. Here I'm going to use Zeke's CW IBC example. This is going to upload the contracts in Python, execute them, and then automatically relay between them based off of our code here. So through Python, it's handling this and setting up the contracts currently. These are being uploaded through WASM. They're cached on the back end as well. So if you upload the same file multiple times, it'll just automatically return that same code ID to you to help speed up tests that have a lot of contracts. The next step, we run the instantiate contract on both of these on each separate chain and get those set up. Once these are set up, we use the create WASM connection command within our Python client and run that on both the source as well as the destination chain, and we can specify those and override any of the features that we need. This is the same case in any other programming language as well. It's a very similar syntax. Now the contracts have been instantiated. We're going to create that connection between them. We can check that all of this is actually running through the relayer here, and we can check that in Docker. That's now been created, and so the connection is full. We're going to execute on one side, and then we're going to flush that. So those packets are now being flushed all through Python down through the stack. And once that's finished, we should see that the incremental counter has increased to 1. It's finished now. And so all of that was written in just standard Python, and we abstracted away everything from the user interacting with that testnet Juno 1. And that concludes my talk. if you have any questions or want the integration either for your network that it doesn't currently have support or another network that was not mentioned, more than happy to do that.
I guess, like, could you speak a little bit to a couple things? One is, like, what if I want to run my chain, like, in something like POA? Two, like, load tests. Do you guys have something like that? Or, like, how do you do that potentially? And then three, like, what if I wanted, like, an arbitrary VM?
Yeah, so the first one with proof of authority, yes, proof of authority chains work through this. We're actually doing that currently through Spawn, a roll chains thing. So you can launch a proof of authority chain. It depends on staking under the head of it. So you're still using staking, so all of the setup is still the same. On the last question with any other VM, as long as the binary itself is running that, we don't need to carry about that on our side. Any interaction is just done through local interchain. So if we don't already have native bindings for that, you just add that into interchaintest, and then we can just hook that up in about 12 lines to the local interchain, and so you get that support. In terms of load testing, we've been looking into this. I'm going to talk with Adam after as well, because we need a fuzz tester that we can just throw a lot of data at, and this tool's, we're at the point that we just need to know what the proper design is for that. So we're very interested in that. There's currently an open issue. We've needed it for multiple things, and we believe in a lot of other teams need it as well. So it's a high priority now.
I'm just a little confused. So I was looking at this and assuming it's just basically like a Docker Compose creator. Can you not just edit it? Like, when he said about adding another VM, I thought you were going to say, oh, you can just throw it in like you throw it into Docker Compose. Can you not do that?
So you can put any chain in here that you would like. So as long as the VM is like, it's part of the application binary, you're just running that application binary underneath. So any VMs that an app supports, you can run through this. It'll run just through the standard startup. Just as you would start a normal node, that would be the same case. Does that make sense?
No, I'm just saying, like, is this not Docker Compose? Like, can I throw something into this cluster just like I would do with stuff?
No, it doesn't use Docker Compose. This is entirely just native Docker. The orchestration is done on the Go side through the Go API. So if you wanted to do something more specific, you would have to call into those. We didn't foresee that. We do have sidecars though, so you can run a sidecar process. That's not in these slides, but you can run something on the side of another process there that would then integrate with these and connect within that Docker network that is created, and you can like hack into that.
So why not compile into Docker Compose?
We don't have, we need to, we just haven't yet. So if it's just been let's get a product out, let's support it. We can probably support Docker Compose as well. That'll open up the use cases and make it more familiar to Web 2 developers. So yes.
Any more questions?
Oh.
Sorry, this is a much smaller question than the previous one, but for the Cosmos contract upload and instantiation, what is the DevX for essentially like inputting the instantiate? Are you inferring things from the contract, or does the developer still need to sort of know the structure of the contract and type that in somewhere?
Yep. So you still do need to know the structure. Here it's just an empty setup. Mm-hmm. There has been some recent work done by the IBC Go team to automatically convert a schema into the native code. We're going to also implement that for this. So you'll have native class types that you can just set and forget, and then that way it's all set up for you. You just add in the values that you want, and so We're going to abstract that away as well. That's just not done currently.
All right, awesome.
Hello. Okay, now you can hear me. One thing that I think would be super cool, I don't know if you want to just take suggestions, but like you might have some of this already, but like metrics and like some kind of like block explorer or front end GUI thing would be super sick as part of doing this. We've had to like recreate that at Skip like many times over and over again. But this seems really sick, and I feel like that would be a huge thing for developers.
Yeah, PingPub would currently work with this, so
nice.
we can use PingPub. We also have a SQL database under the hood that it automatically indexes for you. So we have indexing there. You can build on top of that if you wanted to build something more specific with metrics of the number of transactions that have gone through, et cetera. That's all already there. So I think more metrics would also be better for developers, especially when we get into like the fuzzing section of sending a lot of transactions and seeing how the chain performs. We can build that all into every single chain running.
Does that mean that this would basically come with like a fuzzing suite based on on-chain data?
We want to do that. In an ideal world, we also would allow for external execution. So you could sync from a Pikachu snapshot and then be able to run state through that. You can run transactions. You can replay transactions. We can do all of that. It requires a bit of modification on the app side with the Auntie handler, but we can build all of that out today and run that through here. You can perform actions as other accounts. I think this is similar to Osmosis' solution recently that's built in the SDK. We can do that here too. It just requires a little bit of app tweaking and a couple of environment variables.
Okay, so I have one last question. When?
We could do it in like a day of time to get that done. It's just not been a priority compared to other activities throughout the Strangelove and Rollchains teams currently.
Cool. Awesome. Thank you to Reece.